Is it okay? All right. Hello, everyone. I'm Sue, and this is Megan, and today we're about to present our project about integrating AI to predict stock market price. So, why we care about this problem is because stock market is known as very volatile and unpredictable. And it is acknowledgeable that public sentiment, such as the people's comments or posts on social media platform like Twitter, can impact stock prices. Although how we quantify the impact is a big challenge. So in this project, we want to employ the AI and ML techniques to analyze wordings and sentiment within the tweets. And if this can be achieved, our research can help support the investors or customers to make the informed and data-driven decision making and improve the robustness, accuracy of the current existing financial models. So about our data architecture in this project, we mainly used two data sources. One is the tweet sentiment data and the other is the stock price data. Both data sets cover the 25 most watched stock between 2021 September to 2022 September. And after we join the data set, our dimension of the data is around 60K rows by 10 columns. And we utilize the Google Colab and Git for code collaboration and version control. Speaking of the feature consideration and some data processing steps for the data inputs, we have date, historical stock prices, and stock volume. For qualitative inputs, we have the sentiment scores and words derived from the tweets. So in terms of how we gonna derive the sentiment scores and words from the tweet text, we're gonna using the Hugging Face pre-trained model to get the sentiment labels and scores. And a second approach we use is to directly use OpenAI's GPT 2.0 tokenizer to transform the tweets into tokens and directly predict the stock prices. And our output is going to be the prediction for future stock price movement. So because our data set is pretty big and for the training efficiency purpose, we used a sample of the Tesla data only, and we randomly divided them into 80% as training data and 20% as test data set.
So we used two baselines to kind of give us a sense of how our future models and our main approach is going to perform. The first one is just to see how does the results of the stock data compare with itself when it is compared against time. So that model is done with a linear regression where the input was all of the temporal features and the output is going to be the daily stock price changes, which was the difference between the closing price and the opening price. The mean squared error for this was a 10.389 error. And the second model was a sentiment prediction based on a pre-trained sentiment analysis from Hugging Face. So this one, we took some tweets and we put them into the pre-trained analysis model and we compared the outputs to make sure that the pre-trained model was classifying the tweets correctly. So it was either negative or positively scored between 0 and 1. And there were no neutral tweets in this data set. Everything was either weakly positive or weakly negative if it was reading as neutral. Whereas we had other very strongly positive or strongly negative tweets that were closer to 1. Our main approach was a long short-term memory model. This is a recurrent neural network, which takes in some sort of order along with its predictions. So this means it's going in a sequence. It's excellent for time series type analysis. And it's designed to hold a look back period so that it can predict based off of some moving window over time. When we put in our data into the LSTM model, We ended up using BERT encoded tweets instead of the GPT 2.0 like we used in our earlier baselines, just because it was a little bit more expressive. So these results were converging around some sort of median value. The true price is pretty volatile with stock data, so it can be hard to recognize a pattern when you're predicting based off of encoded and then embedded tweet data. So first we did it on a small data set of just 1,000 samples, so we could get a sense of what was going on. And then we did it over the entire Tesla data set, which was around 37,000 samples. And both of them were still converging around the mean, but you can see that we have better accuracy with the larger data set. The linear regressor performed much better once we added sentiments to it. This was the second part of our approach. So this one, in addition to our initial baseline, which was the temporal features, we added scored tweet sentiments to it, where we added the weighted sentiments of the tweets as a feature, where negative tweets were rated between -1 and 0, and positive tweets were rated between 0 and 1. The mean squared error for this was 3.7843, which if you'll remember from our earlier baseline, the mean squared error for that was 10.3897.
So this is just a graph based on the previous results. So as you can see, the sentiment feature actually plays an important role in the predicting power, and we got the 64% error rate decrease by adding the sentiment feature. Another thing we try to explore is that we wanted to see if there's any correlation between the absolute sentiment scores and model accuracy. So our initial hypothesis is that if the absolute sentiment scores is closer to 1, maybe the model accuracy will be higher and vice versa. However, after we plotting the correlation graph, we can see the variation is very big and there's no clear pattern about the correlation, which is very interesting and indicate that the signs, which is like negative or like positive sentiment tags may be more influential to the predicting result rather than the magnitude of the sentiment scores.
So next steps, we think it would be interesting to introduce some real-time streaming data of stocks and tweets. That would be a very appropriate data set for the LSTM. And I think it can provide some very valuable insights. We also want to integrate some additional predictive features such as interest rate, inflation rate, and other things like that. And then enhancing model optimization through cross-validation and hyperparameter tuning. This would include selecting some additional features or weighting them a little bit differently, depending on the size of the data set, and perhaps maybe coming up with a different way of categorizing neutral tweets. For the LTSM specifically, we want to improve that by adding time parameters. We kind of weakly inherently included those via their position instead of actually based on time and date. So by adding in an explicit time parameter, we think we can improve our LTSM results, as well as investigating different language models for encoding or tokenization. We mentioned we compared the GPT 2.0 earlier to the BERT model. GPT 2.0 uses byte encoding, whereas the BERT model uses word encoding. So perhaps even expanding to sentence encoding might be a better feature for our LTSM. And finally, we saw some improvements when we added a larger data set. So just adding a even bigger data set over more different stocks and tweets correlating to those as well, we think we can improve the model as a whole. With that, that is everything. Thank you so much.